It has been hidden in plain sight for over 2 centuries, a pale blue dot, quiet, featureless, the solar system's afterthought. Every school textbook showed it the same way, a smooth, unremarkable marble drifting silently near the edge. Scientists even joked about it. They called it boring. They named it the planet nobody wanted to visit. And then we finally looked at it properly. Not a grainy flyby image from 40 years ago. Not a smudged dot from a ground telescope squinting across 1.8 billion miles. We looked at it with the most powerful eye humanity has ever built, and the thing staring back was not a boring planet. It was a broken, frozen, poisonous, magnetically scrambled world, rolling on its side through permanent twilight, hiding storms in its atmosphere, raining diamonds in its core. And in early 2025, it revealed something nobody expected, a 29th moon, 6 miles across, invisible to every telescope that came before. We had it wrong for 200 years. The last time a human spacecraft came close to Uranus was January 24th, 1986. Voyager 2 swept within 50,000 miles of the cloud tops, snapped its photographs, and kept moving into the dark. It never slowed down. It never came back. And those photographs showed almost nothing, a blank, featureless ball. No storms, no bands, no drama. Just a pale blue sphere that looked like someone had left a marble on a black table. For the next 4 decades, that single cold portrait was the entire story of Uranus. We had rovers crawling across Mars in high definition. We sent a probe deliberately crashing into Saturn. We flew past Pluto, billions of miles further out, and got detailed surface maps. For one of the strangest planets in the solar system, we had Voyager's blurry snapshots from the year of the Challenger disaster. That was it. Now here is the thing. Voyager 2 did not find a boring planet because Uranus was actually boring. It found a featureless ball because it arrived at the worst possible moment. When Voyager flew past, Uranus was deep into one of its extreme seasons. Its south pole was aimed almost directly at the sun. The planet was locked into a phase of relative atmospheric stillness, a decades-long quiet period driven entirely by its bizarre axial tilt. We happened to photograph the one face of Uranus it shows when it is least active, and we concluded it was dull. It was never dull. We just picked the wrong moment. To understand why Uranus is the way it is, you first have to understand what happened to it. Something enormous hit it. Early in the solar system's history, around 4 billion years ago, a body estimated to be at least twice the size of Earth slammed into Uranus with enough force to knock it completely onto its side. Not a slight lean, not a comfortable 23-degree tilt like Earth. Uranus was knocked to 98 degrees. It isn't spinning like a top. It's rolling like a bowling ball down a lane, and that single fact poisons everything else about the planet. Because when a planet rolls on its side, its poles face the sun directly, one at a time. Each pole spends roughly 21 years bathed in continuous sunlight, and then 21 years in total darkness. Uranus takes 84 years to orbit the sun. If you were born in the wrong hemisphere at the wrong moment, you could live an entire human life without ever seeing a sunrise. The same collision that tipped the planet may have also shut off its internal heat. This is where Uranus gets genuinely strange, even compared to other planets. Neptune, further from the sun, is warmer than Uranus. That should not be possible. Every planet generates some heat from its compressed core. Neptune still glows with internal energy, radiating more warmth outward than it receives from the sun. Uranus barely does. It is the coldest planet in the solar system, colder than Neptune, colder than anything else. Its upper atmosphere drops to minus 371 degrees Fahrenheit, the coldest temperature ever recorded on the surface of Earth, in the heart of Antarctica, in the dead of winter, was minus 128 degrees Fahrenheit. Uranus is colder than that by more than 240 degrees. Antarctica, the most lethal cold a human being has ever measured, would feel comparatively warm. The leading explanation is that the ancient collision somehow trapped the planet's internal heat, sealed it off, or scattered it, leaving Uranus with a frozen core and nothing radiating outward. A planet with its furnace switched off 4 billion years ago, still coasting on the cold. And if the cold somehow didn't finish you, the air would. In 2018, astronomers using a telescope in Hawaii finally cracked open one of Uranus's longest-held secrets. They figured out what the upper cloud layers are made of: hydrogen sulfide. That is the compound responsible for the smell of rotten eggs. So, if you could somehow descend into the upper clouds of Uranus, assuming you survived the cold, the pressure, and the suffocating lack of breathable air, the first thing you would register is the overwhelming stench of decay. The whole planet smells like a cracked egg left in direct sun. The lead scientist on that discovery described it bluntly. An unfortunate human descending through those clouds would encounter deeply unpleasant conditions, but the cold and the suffocation would end things long before the smell became the main problem. That is Uranus in one sentence. It will kill you several different ways at once, and the smell is just the insult on the way down. Everything described so far was pieced together over decades, from one flyby and ground telescopes squinting across nearly 2 billion miles of empty space. Then, the James Webb Space Telescope looked at Uranus, and the resolution on all of it changed at once. Webb does not use visible light. It uses infrared, the kind of light that reveals heat, motion, and structure invisible to ordinary cameras. When it turned that infrared eye onto Uranus, the calm blue marble disappeared entirely. In its place was a world with weather. A massive polar cap glowed across the northern pole, a vast hood of haze that no previous telescope had ever detected. At its center, Webb found a distinct bright region, the signature of a massive vortex, a storm system anchored over the pole, warmer than the surrounding atmosphere, actively churning. Bright storm clouds were scattered across the edges of the cap, dynamic structures that simply were not there in Voyager's images, because Voyager wasn't looking in the right kind of light, at the right moment, with the right instrument. The dead world was alive with motion the entire time. We just never had the tools to see it. Webb also gave us something Voyager could never have imagined: a time lapse. By watching the planet rotate across multiple observation windows, scientists assembled a video of Uranus spinning in space, the storms moving, the polar cap shifting, the rings swinging around the edge of the frame. For the first time in history, Uranus was not a photograph. It was a living system. And then came February 2025. A team led by Dr. Maryam El-Mutamid at the Southwest Research Institute was running a deep imaging survey with Webb's near-infrared camera. They stacked 10 consecutive 40-minute exposures, pushing the telescope to the limits of its sensitivity. And in those images, moving slowly against the background stars, orbiting Uranus in just 9.6 hours, they found something new: a 29th moon, designated S/2025U1, approximately 6 miles across. 6 miles. You could walk the circumference of this moon in a few hours. It is so small and so dark, reflecting barely 5% of the light that hits it, that it was completely invisible to every telescope and every spacecraft that came before. Voyager flew past the entire Uranian system and missed it entirely. It orbits between two already known moons, Ophelia and Bianca, at a distance of about 36,000 miles from the center of the planet, completing a full orbit roughly twice a day. And just months later, in early 2026, came another first. Scientists used Webb's near-infrared spectrograph to watch Uranus rotate for nearly a full day, almost 17 hours of continuous observation. For the first time ever, they mapped the planet's aurora in 3 dimensions. What they found confirmed something that had been suspected but never proven. Uranus's upper atmosphere has been slowly cooling for decades, and the aurora, the glowing ribbons of charged particles driven by the magnetic field, behaves in ways unlike any other planet we have ever studied. On Earth, auroras form in clean oval rings around the magnetic poles, predictable, beautiful, orderly. On Uranus, the magnetic field is tilted nearly 60 degrees away from the spin axis, and it is not even centered inside the planet. It is offset toward one side, as if the ancient collision knocked the planet's magnetism loose from its moorings, and it never reattached properly. The result is an aurora that does not form in rings. It sweeps across the planet in chaotic arcs, 2 bright bands of emission near the magnetic poles, and then, between them, a strange dark region where both emission and ion density simply vanish, a gap in the aurora that the models cannot fully explain. Uranus has been keeping that secret for 4 billion years. It took a space telescope pointed at it for 17 straight hours to find it. But of everything orbiting this planet, one moon deserves its own moment. Miranda. It is smaller than our own moon by a factor of 7. A frozen, roughly spherical rock 293 miles across, drifting in the cold dark of the Uranian system, and on its surface sits a structure that planetary scientists have been arguing about since Voyager photographed it in 1986. Verona Rupes, a cliff. Not a modest cliff, not a geological curiosity, the tallest known cliff in the entire solar system, a sheer vertical drop of approximately 20 kilometers. That is 12.4 miles, straight down. For comparison, the deepest point in Earth's ocean, the Mariana Trench, is about 7 miles from the surface. Miranda's cliff is nearly twice that depth, as a vertical wall of rock rising from a frozen plain. Because Miranda's gravity is so weak, a fall from the top of Verona Rupes would take approximately 10 minutes to reach the bottom. 10 minutes of silence. 10 minutes of watching the wall slide past you. And you would land, if that word even applies, at roughly 200 kilometers per hour. Here is the part that makes this genuinely strange, rather than just extreme. Nobody is certain how it formed. One theory says Miranda was shattered by an ancient collision, broken into pieces that then slowly reassembled under their own gravity, with the interior layers pulling back together in the wrong order, leaving geological chaos at the surface. A moon that died and reconstructed itself, the broken seams still visible. Another theory says intense tidal heating from Uranus's gravitational pull drove internal convection, hot material pushing up from inside, crumpling the surface from below, like a planet trying to turn itself inside out. Neither explanation is fully accepted. The cliff is too large, too abrupt, too perfectly vertical to fit cleanly into either model. So we have the tallest cliff in the solar system on one of the smallest moons in the solar system, and no consensus on how it got there. Miranda is a scar with no confirmed origin, orbiting a planet that is itself a scar with no fully confirmed origin. The damage in this system runs all the way down. Everything so far has been the surface. The clouds, the atmosphere, the rings, the moons. What is underneath is stranger than any of it. Uranus has no surface you could ever stand on. If you tried to fly a spacecraft into it, you would not crash. You would sink. The atmosphere would simply thicken around you, the pressure climbing with every mile until it crushed your ship flat. And you would keep sinking into a substance that is not quite gas and not quite liquid. There is no floor. There is no bottom you would recognize. Just an ever-thickening ocean that swallows everything that enters and gives nothing back. Most of the planet's interior, thousands of miles deep, is a superheated, electrically charged fluid of water, ammonia, and methane. Hotter than the surface of some smaller stars, locked under pressures so immense that it cannot boil, cannot escape. An ocean with no surface and no shore. And deeper still, something almost impossible. It rains diamonds. That is not a metaphor. The methane in Uranus's deep interior is rich in carbon. Compress carbon under enough pressure and heat it precisely, and it crystallizes into solid diamond. The conditions miles down inside this planet are exactly right for that process. And those diamonds, once formed, are denser than everything around them. They sink, slowly, through thousands of miles of hot, crushing fluid, falling toward a core that no light has ever touched and no instrument has ever reached. Researchers have recreated this in laboratories, firing intense lasers at the right materials and watching tiny diamonds form in the shockwave. The physics is real. The rain is real. Somewhere inside the coldest planet in the solar system, in total darkness, under pressure that would reduce any human object to a smear of metal and vapor, diamonds are falling through the dark in absolute silence. Here is the number that should bother you. 1. One spacecraft. One flyby. 40 years ago. That is the entirety of humanity's close-up exploration of the most common type of planet in the galaxy. That is finally, slowly beginning to change. In 2022, the National Academies of Sciences ranked a dedicated Uranus mission as the single highest priority for the next era of planetary science. Above Mars, above Venus, above everything. The mission concept is called the Uranus Orbiter and Probe. The plan is to launch the spacecraft no earlier than 2031, using a Falcon Heavy rocket from Kennedy Space Center. It would swing past Earth for a gravity assist in 2033, then Jupiter in 2035, and finally arrive at Uranus no earlier than 2044. The science phase would last 4.5 years, with the spacecraft completing multiple flybys of each major moon and eventually deploying an atmospheric probe, a capsule that would plunge directly into the cloud layers and transmit data on its way down until the pressure silences it. That probe would be the first object ever to deliberately enter Uranus's atmosphere. We would finally get readings from inside the place where the hydrogen sulfide clouds form, where the chemistry changes, where the pressure begins its long climb toward the diamond layer. The mission carries a projected cost of around $4.2 billion. As of mid-2026, Congress has allocated only $10 million for early formulation, a fraction of what is needed to begin serious development. The people who are currently designing this mission may be retired before it arrives at Uranus. If you started kindergarten the day the design team filed their first proposal, you might be finishing your doctorate by the time the first images come back. That is the price of the outer solar system. Everything out there operates on a timescale that feels alien to the human sense of urgency. Step all the way back. Take in the full picture. When astronomers survey other star systems and count the planets orbiting them, the most common type of world they find is not a gas giant like Jupiter. It is not a rocky planet like Earth. It is a mid-sized ice world, roughly the size of Uranus or Neptune. Cold, hazy, strange. Those worlds make up the majority of planets in the galaxy. We have spent centuries treating them as footnotes. Uranus, the planet we joked about, the planet we visited once and forgot, may be the closest example we have of the most ordinary kind of world in the universe. We thought it was the oddball. It may be the standard. It may be that Earth is the rare exception. Hold all of it in your head at once. A planet rolling sideways through permanent twilight, knocked there by a collision 4 billion years ago that also switched off its own heat and scrambled its magnetic field from the inside. The coldest world in the solar system. An atmosphere laced with rot. An interior where diamonds fall through crushing dark toward a core no instrument has ever reached. A moon with the tallest cliff in the solar system, and no agreed-upon explanation for why it exists. A 29th moon hiding in plain sight for 200 years, found only because we finally looked hard enough. Auroras that sweep in broken arcs through a magnetic field so displaced it doesn't even sit at the center of the planet. And underneath all of that, the thing that quietly changes the stakes of everything. This is probably the most normal kind of planet in the galaxy. Not the exception, the rule. Which means all of that strangeness, the cold, the tilt, the broken magnetism, the falling diamonds, is not what the universe does at its most extreme. It may be what the universe does by default. The thing we were most certain we understood, the dull marble in the textbook, turned out to be one of the most extreme and complex places in the solar system. And the only reason we know any of this is that we finally pointed the right instrument at it. It makes you wonder how many other things we have written off too early. The universe does not always hide its most astonishing places in the furthest corners of deep space. Sometimes it leaves one right outside the front door, painted a calm, unremarkable blue, and waits patiently for us to stop assuming we already understand it. A dedicated spacecraft is being designed right now. If it launches, If it survives the journey, it will take over a decade to arrive. When it does, I don't think Uranus is done surprising us.